Right. Did we get to try this one? I suggested you try it now. How was your chemistry exam? Was it? You said you had a chemistry exam on ideal gas law. No?
But
no,
they
didn't.
won't use it then.
Oh yeah, well I expect so, yeah. Let's have a look. A cylindrical gas tank, I should say of radius 30 centimeters and height 1 meter. Okay, so let's draw that. You've got a tank and its radius is 30 centimeters and its height is 1 meter. It's filled with helium and the tank is at a temperature of 26.85, so that means the temperature of this is 300 Kelvin, and therefore the tank's at this temperature as well, because that's the temperature in the room, and the tank is at a pressure of 3 atmospheres, so the pressure in here is 3 atmospheres. Yeah? And my first question is, how many moles of helium are there? So, this is A part 1. So you have PV equals N or T. So N is PV over 4T. So if I just take out the calculator, the pressure is 3 times 101.325 kilo pascals. Is that an atmosphere? Yeah. Times the volume, and the volume of a cylinder is pi r squared h. Pi r squared h over the ideal gas law constant times the temperature in Kelvin. So in total we get 34.48 roughly moles. That's happy enough with that? Yeah. Part 2. How many molecules? Well, that's N, Avogadro's number times the N here. So if I just multiply this by, what's it, 6.02 times 10 to the power of 23? 2.075. Is there a mistake? No? Problem, guys? Molecules. Part 3. How many atoms? Is helium diatomic or not? Just one atom. So it's the same. Yeah. So that's the A part, so that's straightforward. Now the B part, some gas is allowed to escape and the pressure drops to 2 atmosphere. How many moles of helium are in the tank? Well, that's actually not so bad. There's actually a quick way I can get this. What would I have to do? If I just open up my calculator and go back to this calculation, but change this 3 to 2, because there's 2 atmospheres of pressure, then straight away I have the answer, 22.98.
So we just change the...
Just change the 3 to 2, because that's the only difference. When the gas escapes, the only difference in the tank is the... Well, I mean, not the only difference. The number of moles is less. And the pressure is less, and you know what the pressure is, so you can know what the mole number is. So therefore, how many escaped? How many left the tank? Well, obviously the difference is 34.48 minus 22.98, isn't that? So that's a 20. Is that 12? 11? What am I doing? 23, 7, 8, 9, 10, 11, 11 and a half. Yep. Where did I get 22.98? I just opened up my calculator, which still, and just went back to where I calculated 34.48, And just the only thing I had to change in that was the pressure. Went from a 3 to a 2. The volume's the same, the temperature's the same, everything else is the same. Yeah. Is that okay? This is 11 and a half, right? Okay, part 3. What was the volume of the escaped helium? So the helium that left, it has a volume. What is the volume? Well, we'll have to use this formula. So we can say V equals nRT over P. Okay, so let's type that in now because that's a different formula. So let me just clear this. Okay, what N should I use?
And
11.5. Is that clear? Because it's you're looking at the helium that escaped, right? The R, 8.31. The temperature, 300, because I said it's 300 Kelvin in the room. So. And the pressure?
1.
Very good. Now why 1?
No. The room is 1.
I thought you had it, but you don't. He has it. What is it?
The room temperature is 1.
The room what?
Room pressure.
The pressure in the room is 1, because remember we said 1 atmosphere is the pressure, at sea level in in a room. So the tank is at 3 atmospheres, but the room is at 1 atmosphere, because that was the definition of 1 atmosphere. The pressure in a room at sea level. So in fact, I need to put in 1 atmosphere, and I'll get my volume. It's 0.283, about 2829 meters cubed. Yeah. And finally, if the tank was left open until no more helium escaped, then how many moles of helium are left in the tank? So if you open the tank and the helium comes out, the helium doesn't keep coming out until the tank is empty, because that's not what happens. The helium keeps coming out until what happens?
Pressure.
Until the pressure is equal. Because think about this, if the helium kept coming out of the tank, then there'd be nothing left in the tank, and all the air would rush into the tank. But that's not what happens in real life. What happens is, when you open the tank, the helium will keep coming out until there's not enough pressure to push more of it out. And when will that happen? When the 2 pressures are the same. Yeah. So actually the question is just a difficult way of asking you something simple. How many moles of helium are in the tank if the tank is at 1 atmosphere? So if I just go back to my formula earlier, and change that 3 to 1, then the answer is 11 and a half about. Now, you might be thinking, so when all the helium comes out, there's actually still some helium left in it, it's at 1 atmosphere, and it's at 1 atmosphere. Yeah, that's true, but if you leave this long enough, like if you leave it open for a few hours or a few days, and you come back to it, there won't be helium in it anymore, because what's going to happen is, on the boundary up the top, some of the air will swap places with the helium. It's not like that's how much helium is left there, but it's not like it will stay there forever, because the air and the helium are going to swap places on the top. And when the air is on the top and the helium is here, because helium is lighter than air, what happens to helium? It floats, yeah. So the more helium will rise and some air will sink down. So in other words, the air and the helium will swap places, and all the helium will eventually leave. But you kind of know this when you ever bought a balloon as a kid, and it will hang around the house for maybe a week and it will still float, but then after a week, will it still float? It won't, because what's happening inside the balloon, even though there's helium trapped inside the balloon, it's actually very difficult to contain helium. So the helium and the air actually swap places at the boundary. Helium really it's very easy for helium to move through things. You know, like you would need a very, very good container to hold helium and to hold hydrogen. These gases, they really want to leak out. Yeah. I take it this is more difficult than what you've done in chemistry. Much more difficult?
Not already.
Little bit. Anyways, can you write down whatever you need to write down and we'll continue.
I want to ask, when do we use it pressure as atmosphere, and when do we use it as 101?
Really, you should never use ATM in a calculation. You should always convert it to 101.325.
Yeah, but didn't we use it in CC?
Well, not really. I gave you the pressure in atmospheres, but you should convert it into pascals.
Okay, when you put it in the calculation.
Oh yeah, I typed in 101.325. Yeah. Is it 325 or 352? I always get this mixed up. Is it? It's on the calculator. Let me have a look.
And even in B1 you did
325. Yep, I did. Did you write that down? Yeah? Okay, let's continue then. Right. The next lesson is not so difficult. Just to double check to make sure we're on track, when exactly is the Easter break? The
30 is bank holiday.
30th is a bank holiday, yes. And do we have physics class on a Friday? We have 1 hour, don't we? Don't we? I think so.
Friday.
We have 4 weeks.
We have one class? Yeah, one class.
No, actually, we only have 3 weeks because the principal wants to have the exam before the break. But I don't know if it'll be better to have it after the break. 3 weeks. We have 6 classes a week?
Yeah.
Oh, it's tight. So I still have 12 from the next chapter, and then 1, 2, 3, 4, 5, 17. Yes. I can't change it now because I've already submitted it. Anyways.